Check. Check. Okay. Hi all, if you can hear me, please say yes on the chat. Please say yes on the chat if you can hear me. Hello, hello. Please do say yes on the chat if you can hear me. Hello, hello everyone. Please say yes on the chat. Hello, hello, hello. Hello. If you can hear me, please say yes. Please say yes if you can hear me. Hello. Okay. Hello, hello. Hello, hello. Hello. Can you hear me? Hello. If you can hear me, please say yes on the chat. Please say yes on the chat if you can hear me. Hello. Please say yes on the chat if you can hear me. Hi everyone. If you can hear me, please say yes on the chat. Coming? Okay. Very good. Right, everyone. Check, check. Check, 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 check. 1, 2, 3. Check, check, check. Check, 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 check. All right, everyone. So the first two rows are still empty. Either two options. What are two options? What two options I gave you? Come front or arrange the chairs. You have to do one of them. Without doing one of them, I am not going to start session. You can sit like this till 3:30, no problem. Check, check. 1, 2, 3, 1, 2, 3. Check. इसमें? Check, 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 check. Check, check, check. Check, check. So, boys side, 4 more seats are here. Till these 4 seats are complete, I am not starting. Either somebody sits there or you arrange them. Either of them is fine. Okay. Pen. Everybody is ready with pen. Show me your pens. Notebook. First benchers, come on. Notebook, where's notebook? Backbenchers. Backbenchers. Pen, notebook. Last row, last row. His notebook? Okay, you are sharing one notebook. Very good. Very good. Both same notebook. Good, good. Enjoy, enjoy. Girls, everybody has pen, notebook. Very good. Somebody give him pen quickly. Front bench. You all have so many notebooks. You're carrying all your friends' notebooks. Very nice. You have pen? Shall I give you pen? Yeah? Okay. Re please, please return it to me at the end of session. Okay? And don't bite or anything like that. My bad. Okay. All right, everyone. So we started Python programming sometime last year. When I say last year, meaning in 2022. You just came to college. Within first week of you coming to college, we started Python programming. Yes, right. We did a lot of programming. We did one hackathon also. Codathon was done. I think last to last week we have done one online session also. Yes, you remember? So we are continuing from there. Our program this time is today, tomorrow, and day after tomorrow. That is today's Tuesday, Wednesday, and Thursday. All 3 days we are going to be finishing up all of the remaining parts of Python 1. Means everything that is in your syllabus, we'll try to finish it by that time. If you don't cooperate and we don't finish, then Friday also I will take session. Okay. Why? Friday we can take, no? No, why? What happened? Freshers. Okay, so you have to cooperate with me. Yes, if you are, what is meaning by cooperation? Like this. Now time, we wasted almost 20 minutes in this. In 20 minutes, I could have covered one topic. If you don't cooperate with me, I will tell your faculty, no, freshers, I need 2 hours of freshers. As more and more time you take of mine, more and more time I'll take from freshers. Okay? Understood, everybody? See, you can ask them also. I am here till Friday. My return travel is Friday evening only. So I'm coming to your college on Friday. If you don't cooperate with me next 3 days, I will take time on Friday. Okay? So if you want your freshers properly, please cooperate. So cooperation is one. When I tell you to come front, please come front. Right? When I tell you to take out your pen, paper, notebook, do it quickly. Every minute that you waste, I am taking from your fresher. Okay. Second, when I say cooperate, when I ask you question, if everybody is silent, then I will also stay silent till somebody responds. So you can take 1 hour to respond. 1 hour will go from fresher Friday. You respond quickly, you give me answer quickly, we'll go to the next topic. That's all. Okay. So now quickly tell me, in the last class, what are all the topics we have covered? In the last class, the online session that we did, what's the topic we covered? Pattern. Okay, printing. What else? Pattern printing comes under which topic? Nested loops, very nice. Okay. In pattern printing, there are 4 rules we follow. In the formula, there are 4 formulas or 4 steps in the formula. Can you tell me what are those 4 steps? Whenever you get a pattern printing question, what is the first thing you should check? What should you do? Louder, please. Analyze the problem. How to analyze it? Very good. Don't laugh at him. It's the correct answer. At least he is having the courage to say the answer. You are not even giving the answer. Right? Okay. So what should we do? The first thing when we get the pattern? Check rows and columns. That's the second and third step. What's the first step? What's the first step? Somebody help that girl. I think she needs some help. That girl. She's needing some help. Yeah, please go help her. Yeah. Okay. What's the first step? Try same pattern with different inputs. Correct. You just say that. Your correct answer only. You should say it. Okay. Next one. How many rows? Then how many columns? And then what are we printing? Right. So when you say what are we printing, based on rows or row number, based on row number, what is the pattern? Right. So for example, based on row number, we might print 2 dots, 5 stars, and 2 dots. You remember this? We covered this in the last online session. You remember this one, everyone? Okay, very nice. So today we are going to start with the concept of lists. We already did, right? Last time lists. Remember lists? What are the some of the things in lists? How do you add element at the end of a list? Append, very good. How do you insert in the middle of a list? Insert, very nice. How do you remove from a list? Pop, very good. And remove as well. Yes. How do you check length of a list? Len, very nice. Okay. So these, how do you check the indexes? Like what's the first index in the list? 0, right? So you start from 0, ARR 0, ARR 1, and so on, right? How do I check the last element of a list? What? -1? ARR -1, right? So of a list, ARR -1. So this is all we saw already. Last time, when I was here in your campus, we discussed lists, right? Hope you're all revising. My friends, the notebook, pen, etc. is not to just keep in your lap. It's to write things. Okay. So as in when I'm saying things, you should write it. Okay. So anyway, so this is what we covered last time. Today we are going to look at concept of 2D list. We're going to look at the concept of 2D list, which is basically list inside a list. Okay, we look at this and then we'll also look at some important algorithm. Okay. Right. So I'm opening the Python console over here for now. I'll open this Python console. And in this console, let me create, let's say, a list of subjects. Okay. So let's say physics, chem, let's say maths. Right. So this is a list. Yes or no? Okay, very good. So this is a list. How do I get length of the list? Len of subject. So len of subject is 3 over here. Okay. Is it that in the list I can only have strings? Can I add other things also? Okay. How do I add? Let's say at the end I want to add the number 100. How to do that? Append. So I'll type append like this. Very good. Subject dot append, then 100. If I did this, 100 gets added. Okay. Now let's go back here. I said subject is equal to physics, chem, math. I want to add another one, which is social studies, but I want to add another list inside. So what I did here is I added another list. In this I put, let's say, geography, history, and let's say civics. Okay. So now what I have is I have a list inside a list. Now let's look at this subject list properly. In the subject list, are all the elements lists? I'll repeat the question. In the subject list, are all the elements lists? Are all the elements strings? No. What do we have? First element is a string or list? String. Second element is a, third element is a, fourth element is. How many elements do we have in our subject list? If I do len of subject, I will still get 4. Okay. Is it visible to everyone at the back also? Okay, you should tell me that time. Yeah. Now what to do? Should I increase it? Is this more visible now? How about now? Okay. At the back? Yes. And if you want better view, come to the front. Okay. So len of subject is 4. Right. So I'll just 1 second, just clear this again and just say this is subject and len of subject here is 4. Clear everyone? Okay. Now, if I do subject of 0, what will I get? Very good. If I do subject of 3, what am I going to get? I'm going to get another list. I'll get another list. That list itself is a basic, sorry, I'll get an element which is itself a list. Okay. So now if I did subject of -1, what will I get? Excuse me. Geo, history and civics. Now if I did subject of -1, now I want to get only geo. How do I get geo? Louder. If you don't say, I'll wait. Subject of, I want to just get geo. How to get geo? Bracket 0. Very good. Gives me just geo. Why that happened? First subject of -1 is what? It's the list. Of that list, I'm asking for the 0th element. So I got geo. Now tell me, what will be the output of subject of 1? Chem, just one element. Okay. If I did subject of -1 of -1, what will I get? Civics. Take the last element, which is list. In that also I want the last element. So I got civics over here. Clear, everybody? This is what you do, list inside a list. You can have another list inside this also. Okay, so you can keep putting lists inside lists, not a problem. Now, in our use case, the major use case that we will see is we will use 2D lists for one mathematical concept. Do you know which maths concept I'm talking about? Yes? Matrix, very good. So, matrix, we will use 2D lists are used. We'll use 2D list to represent a matrix. What is meant by a matrix, everybody? Matrix or matrix, what is meant by it? Rows and columns. You'll have like it's almost like a table. You have rows and columns, and you have only and only numbers in it. You don't have strings or anything inside it. Okay. So, for example, if I give you, say 1, 7, 9, 8, 7, 8, 6, 2. What are the dimensions of this matrix? If I just talk in this matrix, 2 by 3. So 2 rows by 3 columns, right? So this is a matrix. Now, if I look at something like 1, 9, 0, 4, then 2 by 2. And do you remember there is another concept associated with matrix? What is that concept? One calculation we do. What is that calculation? Louder. Determinant. Very good. Determinant. So determinant in 2 by 2 is different. 3 cross 3 is different. Do you remember this part? Yes. Okay. This is all in maths. Now, what we want to do is we want to represent matrices in the form of a 2D list. We use matrix to we use 2D list to represent matrix. For example, if I have this 1904, the way you will represent this is 19 is a list. 19 is a list. 04 is also a list. And these both are inside another list. So our matrix is actually just a list of lists, where each row is a list. Clear on this part, everyone? For example, if I want just the first row, let's say matrix is here, matrix is equal to like this, right? If I want just the first row, and I'll just put a column here, comma here also. Okay. So if I want just the first row over here, how do I get only the first row? How do I access only the first row over here? Mat 0. Very nice. What will this give me? 1, 9. This will give me a list 1, 9. If I want only the second row, mat 1. Very good. Now, if I want the number 4, how do I get the number 4? Mat 1, 1, 1 or 1, -1. Both will be fine. Okay. Let's try it out over here. Let's say mat is equal to 1 second. It's stuck. Just wait 1 second. Okay. So what did we say? We said mat is equal to 1, 9, 0, 4. Okay. So that's the mat. If I look at mat like this, it will show me like this. Okay, if I show mat, it's going to show me 1, 9, 0, 4 over here. Now, what after that? If I wanted to just get 4, what will I do? I'll do mat 1, 1. I got 4. Okay, clear everyone on this part? Okay. Now let's look at how to take input one particular matrix. I'm looking at taking input of a matrix. Okay. The format that you're going to be given the matrix is like this. I'll just hold on. Okay. So the format that you're going to be given the matrix is like this. You will be given 2, 3. 2 is the number of rows, 3 is the number of columns. 2, 3 is just example. You can get other ways also. So 2, 3, and then you will get something like 1, 3, 5, 6, 8, 0. So this is 2 cross 3, everybody? Yes? Okay. Before we go on to matrix, do you remember how to take input just one list? One list, not 2D list. One list. Do you remember how to take input? Yes, no? List, map, int. You remember this part? Yes or no? Yes or no? Very good. I'll explain it. Don't worry. You have to say one thing. Okay. Let's go back to 1D list. Okay. 1D list is something like this. I will give you input 1904876, and this should become one single list. How do we take input a single list of integers? How to do that? We will do it like this. You can memorize this also. Please note it down and memorize it. Okay. Array is equal to list map int input dot split. Okay. What this means, we'll go step by step. Okay. Input dot split. Let's look at what input dot split does. Okay. See. Let's say I do k is equal to input, and I give you 1904. What is k? Louder? String. K is just a string of 1904. But what I needed? I needed integer list. I need integer list. Is this integer list? No. If I did k equals to input dot split, and then I do 1904. So what it's saying is take input and split it into a list. So now I look at k, I get list. But is it list of integers? Yes or no? What I need list of integers. So what I do, and this is why we use a special formula here, we say take this integer function and map it to this list. Input dot split is a list. This is the list we saw over here. Map it to that and then create a list out of it. That is the meaning of this function. Everybody please write it down, this one. This is how you take input a single list of integers. If you want to take input list of strings, simply do input dot split. That will anyways give you list of string. Okay. For example, let's look at it here. If I had k is equal to input dot split, just this, it will give me a list of strings. So if I had something like physics, chem, bio, math, now look at k, automatically I got list of strings. Reason I use list map int. What's the reason of using list map int? What's the reason? What's the reason? Louder. Why did I use list map int? I want list of integers. I don't want list of strings. Very good. Okay. Now, this is how to take input list of integers. What I want to take input, but we came here, but we started with something else. What was that? 2D list matrix. So matrix, what you're going to be given is You are going to be given dimensions 2 and 3, and you are supposed to take 2 rows. Each row is a list. Correct? Each row is a list. Okay. Now let's look at this. If I had something like row is equal to list map int input dot split, let's say like this, and here I gave 192. So my row is like this 192. Is it 2D list? Is it a 2-dimensional list? No. What I want to do is, this is the first row of my matrix. So what I will do is, I'll create matrix is an empty list. This is my first row. I want to put this row into my matrix. How do I put this? How do I take that row and put it into my matrix? Into my mat? Very good. Append mat dot append row. Now what I got mat as is a matrix having how many rows? 1 row. That row is 1, 9, 2. Now I did again row is equal to list map int input dot split. Let's say I did this again, and this time I give 9, 6, 4 as the input. My row is this. I want to put this as the second row in my matrix. How do I do that? Mat dot append row. Now I look at row. Sorry, not row. Now I look at mat. Does it have 2 rows now? Yes. Correct, everyone? So how to take input matrix? First take input that row, add it to the matrix. Again take input another row, add it to the matrix. Okay. How many times we'll continue this? Here it's 2 times. If the input was given not 2 by 3, but it was given 7 by 3, how many times you'll do it? 7 times. So as many number of rows there are, that many times you will repeat this process. Okay. Meaning, should I write this input line 7 times? Should I write it 7 times? Yes or no? Then what is better way? Louder? For loop. Very good. So I am given something like this: 7, 3. 7 is number of rows, 3 is number of columns. Let's make it 4, 3. 4 is number of rows, 3 is number of columns. Okay. This is the input that's given. So I will say, let's take rows, number of rows is equal to input, is equal to int input. This value is 4. Then I'll do columns. Columns is equal to int input. This value is, what is the value here as per this example? 3. Now what I want to do is, I want to repeat, I'll say for I in range rows. I want to repeat 4 times. And what I want to repeat? I want to take input 1 row, add it to the matrix. So first I'll create empty list here. Matrix is equal to empty list, and I'll say current row, instead of row, I'll say current row is equal to list map int input dot split. Okay. I've taken input the list. Then next, what should I do? I took input 1 row. What should I do with that row? Append it. Mat dot append current row. Okay. So let's try this now. First, I need to enter the number of rows. So that is 4. Then I need to enter the number of columns, which is 3. Then I need to enter each row. Okay. Okay. Let me just rerun this. I have not printed the matrix, so let me print the matrix here. Four, 3, And then let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 9, 8, 2. Let's say. Okay. So now we got a matrix with 4 rows. Now we got a matrix with 4 rows over here. 1, 2, 3, 4 is the first one. So now tell me, if I want to get the number 10, how do I get the number 10 over here? 2. Okay, I'll get 10. Everybody understood how to take input? What we did, we first took how many rows to take input. First, we have to understand how many rows are needed. So that tells me here, these many rows. How many columns are needed? Actually, in Python, even without columns, I can do it. Because this, when I take input the entire row, it doesn't matter how many columns are there. So that is one good part. Still, I took input the number of columns. I created an empty matrix. Created an empty matrix over here. And then after that, what I did was for I in range rows. So repeat these many times. If there are 5 rows, you repeat 5 times. If there are 3 rows, repeat 3 times. At each time, what you're supposed to do, take input that row, take input that particular row, and append it to the matrix. This is how you take input a matrix. Okay? Please write it down quickly. Okay. Next, let's see how to print a list. Print a 2D list. How to print a single list? Let's say it's just 1D list. How to print that? Let's say I have just a 1D list here. Let's say ARR is equal to 19350. How do I print just a 1D list, single list? If you don't cooperate, I'm going to take Friday time. Telling right now. I asked question. Either you say something or you say we don't know. What's the question? How to print 1D array, 1D list. Very good. How to print it? Print. Okay. Let's say I did this. This will print with the brackets. If I want to print without brackets and comma, end parameter. No, end parameter is for different thing. What else? What else can I use? So I get the answer. Nobody is revising, right? If Anik sir is in campus, we will do some programming. Otherwise, why to do programming? No? Nobody is revising anything. Okay, be happy. I don't mind. Anyways, anybody remembers how to print? They don't know. Girls, you know? No? Nobody knows? Okay. Do you remember this one? For X in ARR, print X. For each loop, you remember this one? So it prints one by one like this. If I want to print in straight line, how to do it? Huh? End like this. Right, everyone? There was another way of doing it. This is using the for each loop. There is another way which is the using the indexes, which was like this. For I in range len ARR print what? ARR I. Okay, so this is to print 1D array. Now, if I want to print a 2D array like this is the given 2D array to me. This is the given 2D array to me. Quickly. All right, so this is the given 2D array for me. What I want to do is I want to print each row one by one. How do I print each row one by one? What's the first element to be printed? What's the first element to be printed? Then first element to be printed is 1, then 2, then 3, then okay. If you write in terms of indexes, first element to be printed is matrix of 0, 0. Then matrix of 0, 1. Then matrix of 0, 2. Then matrix of 0, 3. Once we've printed one row, then next what to do? matrix of 1, 0. Then matrix of 1, 1, and so on. Then after that, matrix of 2, 0. So you understand what's happening here? We are first holding row 0 and printing all of the elements of the first row of that row. Then holding row 1 and printing all the elements. So how to do that? What we will say is, we will print matrix I comma j, meaning I will be 0. For I 0, j will be 0, then j will be 1, then j will be 2, then j will be 3. So matrix 0, 0, 0, 1, 0, 2, and 0, 3. Okay, everyone? Then what will happen? What will happen after that? What will be 1? Quickly. I will be 1. So you have to say, you are not babies. Right? You have to tell proper sentence. Then, sir, value of I will change to 1. Say that full sentence. Okay. So I will change to 1. J will be 0, 1, 2, 3. Very good. Then I will change to, very good. Then 0, 1, 2. Okay. Till how much I will go? 3. 3 will be the last one. Okay. So you'll have 0, 0, 1, 2, 3. If I want to write this in terms of for loop, how I will do? First, I will write for I in range. How many rows are there? How to find that out? How many rows are there? I'll do len of matrix will tell me number of rows. Okay. So if there are 4 rows, what will this len of matrix be? 4. And what will be the value of I? 0, 1, 2, 3. Will it go to 4? Why it will not go to 4? Why it will not go to 4? So start from 0 and range will never go till the number. It will go till n minus 1. Range of, let's say it's range of 7. What will be the answer for range of 7? 0 to 6. Okay, so range will never include the number. It will start from 0 and go till n minus 1. Okay, so for I in range len of matrix, so what? This will be 0, then it will be 1. Now when it is 0, what should it do? When I is 0, what should happen? What should j be? J should go from 0, 1, 2, 3. So it should be for j in range. How many columns? How to find out number of columns? I will say len of this row. What is this row? How do I get this row? Mat 0. I can either say mat 0 or I can say mat I. Assuming all the rows are of same length. Okay. Let's say mat 0. What I want to do is I want to print matrix I j and I'll give a space. Once I am done printing this entire columns, all this j are done, I will print a new line here. So what I'm saying, after I'm done with printing one row, let me print a new line over here. So now I'll just comment this part out. This is the matrix, initial matrix given to us. And we'll try to print this. Hold on. Some bracket is not matched. Here, extra bracket came. Okay, so becomes 1, 2, 3, 4, 5, 6, 7, 8, and then so on. It prints the entire thing. Clear, everybody, how to print a 2D array? Yes or no? Yes? Please write it down quickly. Done, written? Okay, very good. Now let's look at another example. Same matrix. I don't want to print like this. I don't want to print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 0, 9, 8, 2, like in a row wise. I want to print column wise. Meaning I want to print 1, 5, 9, 0. After that, I want to print 2, 6, 10, 9. Then I want to print 3, 7, 11, 8. And then I want to print 4, 8, 12, 2. Okay. How to do this? First, let's think of indexes. As per my requirement, what do I want to print? What's the first index I'll print? Matrix 0, 0. Then next, what will I print? Matrix 1, 0. Very nice. Then matrix 2, 0. Very good. Then matrix 3, 0. Okay. After this, matrix 0, 1. Because 2, 6, 10, 9. Right. Then after that, matrix 1, 1. Then matrix 2, 1. Then matrix 3, 1. Okay. And so on. After this will come matrix 2. Then matrix 1, 2. So what is being constant in every one of them? In the first one, what is constant? 0. What is 0? Column number. So J is constant here. Here, what are we doing? We are saying keep J 0 and then make I go 0, 1, 2, 3. Yes? Then here we are saying make J as 1 and then I goes 0, yeah, 0, 1, 2, 3 and so on. Okay. So what I'll do here is it's the same thing. What I want to do now is I'll say I want to keep, let's say, J constant. So J constant, I should go 0. Okay, 1, 2, 3. Now, to be careful here, J that you see, J has to be constant. How many columns are there? How to know number of columns? Len of mat of 0. And here it will be len of mat, the number of rows. That's important to know. Okay. And now I'll print matrix of J. No, so it will still be matrix Ij. But now J is being kept constant. How J is constant? Because J is in the outer loop. I is in the inner loop now. Everybody understood this part? Now if I run this, I should comment this also. I should comment this part. Okay. Is it coming in that way? 1, 5, 9, 0, 2, 6, 10, 9, 3, 7, 11, 8, 4, 8, 12, 2. What is this called? What is this called? This is called something in matrix. What is it called? Transpose of a matrix. Very good. So when you invert the rows and columns, it's called transpose of a matrix. So this is how you can print the transpose of a matrix. You can write this down. This is transpose of matrix. Please write it down. Done? This part done? Yes, everyone? Okay. All right. Now let's look at something else. Let's go back to our 1D list. Okay, let's go back to our 1D list, which is something like this. 2, 8, 9, 0, 3. Let's say. What I want to do is, I want to see, let's say I give you key. Key is equal to 10. I want to know if this key exists in this list or not. Does the 10 exist in the list that I've given you? Come on. No, right? It does not exist. How to find that, whether it exists or not? Yes, louder. So I take that here. Let's say this is my list. And I want to find out if my key here is 10. Let's say key is equal to 10. Is the key in the array or not? I can do something like key in ARR. This in keyword will tell you whether something is in that list or not. The output is going to be either a true or false. It's going to be a Boolean value, true or false. So to key in ARR, false. Okay. Now if I did 9 in ARR, what will it give me? True. Right? So it gave me true. This is checking for whether the element is there or not. This is using the in keyword. If I want to do without the in keyword, meaning you're not allowed to use in, how can we try doing it? For loop, very good. How will I do it using for loop? So I can say for I in range len array, if ARRI equals to key. This means it's equal, means it exists. Yes or no? Okay. When I'm asking a question, say yes or no. Does this mean key exists or not? Yes. So let's say print, let's say f strings, key exists. Okay. Now, when do I know if the key doesn't exist? In end of for loop, what will I know? How to, if it exists, very good. But how to find out if it doesn't exist? Else here, doesn't exist. Okay. All right. So let's try this. 10. It doesn't exist, right? Or let's try 9. 9, it should say it exists. Correct? Let's run this. Doesn't exist, doesn't exist. 9 exists, doesn't exist, doesn't exist. Why is it doing that? If you look at it, first it's compare 9 to 2. Is 9 equal to 2? So what will it print? Is that correct to do? Should it print doesn't exist over here itself? No. Why? It's not checked the remaining elements. So putting else here is wrong. Correct? What else can I do? Think logically, think everyone, think. Use the brain, think logically. Without, forget Python right now. You forget Python right now. Okay. Just think logically. There is a list of elements. I'm searching for something. Until I have gone through all the elements, I can't say it's not there. Right? Let's say some friend comes here. They're searching for someone. They don't know any of you. They just know that person's face. What that person will do? He will go through each and every one and check, is this face equal to that person's face? Right? And if it is, he'll say, yes, this is the person. Only when he is exhausted or finished everybody's faces, then only he can say, it is not that person. Understood this point, everybody? Okay. Somebody from other college comes, they're searching for you. Okay. There's a criminal over here. Big wanted criminal is there. 10 lakh rupee prize you will get. He's hiding here only somewhere. Okay. He has a wanted photo. You know, you see in movies wanted, right? The photo is there. He's going through each and every person to check if that person is the same or not. After looking at two people, can he say it is not here? No. He has to look at everybody's photo, right? So after looking at everybody, then only he can say it is not here. How do we do that same thing over here? After we've looked at everybody, then we should say that it is not there. Correct? Remove else. Okay. Then here, else here. Like this. Okay. Let's see. So it says 9 exists and doesn't exist. Still problem? Yes? Okay. This is what we are going to do. Forget the else part. Forget the else part. Just look at it like this. Let me initially assume. Let's take a flag. What I'll do is, I'll tell my friend outside. I'll take 2 people. Right? I'm from the police. Wanted criminal is over here. I tell my friend, my fellow police inspector, you stay outside. For you, I have not found him. So far, I have not found him. If I come outside and tell you I have found him, means I found him. But if I come outside and I still don't have any result, it means I've not found him. Meaning that initially you say flag equals to 0. Meaning, let's assume I have not found him. When ARRI equals to key, you should say flag equals to 1. Now I put a flag. Hey, I found this guy. Okay. Now when the for loop is over, what will I do? I will say, let's check if flag equal to 1. Meaning, if flag is 1, who made flag 1? Only if it exists. So instead of flag equal to 1, let me put flag equal to 0. Meaning, I went through the entire for loop. Not even once it was changed to 1. So I will say if flag is still 0, then I'll say, oh, print key doesn't exist. Okay. You can print key doesn't exist. Why? Because I kept a flag over here. Initially, I assume I have not found him. If you find it, change this flag. Otherwise, don't change it. Leave it as it is. If it's still as it is, means key doesn't exist. Now let's look at it. Now it will say 9 exists. But if I am looking for 10, it will say 10 doesn't exist. Understood this one, everyone? Yes? We used concept of flag over here. Same concept, instead of flag, you can use a Boolean variable. I can say found equals to false. I'm saying found is false. If I did find it, if array of I equal to key, I'll say found equals to true. Hey, I found it. And I'll say it exists. And in fact, I can even say break. Don't look further. You found it, no? Why are you looking further? You remember break statement, everybody? Break statement breaks the immediate for loop. So I say, oh, you found it. No, break out. Don't look further. And here, instead of flag equal to 0, just say if found equal to false. So that means if it's still false, if the found is still false, then what do? You print doesn't exist. Okay? Clear, everybody? This process of checking each element one by one, this process is called as linear search. What is it called? Linear search. Why linear search? One by one, we are checking all the elements. It's called linear search. Please write it down. Now you'll say, sir, in keyword was there. No, why we are doing all this? In keyword also does the same thing. Python in keyword is doing the same thing, except it is doing it inside. It is not doing it in front of you. It's doing it inside. So you can use the in keyword also. In interviews, if you say in keyword, sir, then interviewer will not be satisfied. They'll say, okay, if you're not allowed in keyword, how to do it? You should know this way. So for interviews, this is very important. This is linear search. Done, everybody? Yes, noted down. Okay. We'll look at one more algorithm now. This is an important algorithm which we saw, just called linear search. We'll look at another algorithm. You might have already studied it. Can you guess what's the next algorithm? Binary search. Very good. So binary search works like this. Let's say I give you a sorted list. This entire list is sorted. Okay, there is a list I've given. It's a sorted list. Let's say in this sorted list, there are 100 elements. How many elements? 100 elements. So if there are 100 elements, means what are the indexes? 0 up till 99. Very good. So 0 all the way up till 99, you have the element, the indexes. Okay. I've also given you that this array is sorted. List is sorted. So sorted list. It's not unsorted, it's completely sorted. Now, if the list is sorted and I'm looking for a number, so let's say I'm looking for key, which is equal to, let's say, 206. Okay. What I'm doing is I'll first go to, let's say, index 50. I'm just taking a quick peek. Okay. Peek, just opening and checking. So I check here, 50, and I look at it and I find out there's a number 150. I am looking for number 206. But right in the middle, I looked at 150. So what does this tell me? Where can 206 possibly be? Where? 50 to 99? Can it be at index 50? No, right? Because index 50, number 150 is there. So which indexes can it be at? 51 to 99. So what this means is, if array of 50 is 150, this means key is in range or in between 51 to 99, which means everything from 0 till 50th index is not to be considered. Okay. Next, let's check again somewhere in between. Let's say I check here at index 75. And I found that at index 75, the number is 310. If array of 75 is equal to 310, then what does this tell me about key? Key is in between 51 to 74, not 75. Because again, 75 we already know is 310. If 75, okay, let's go again in between. Let's say somewhere in between. What would be in between over here? Let's say 62. Right? So let's say I open up 62 over here. And 62 is 206. Then we found our number. Correct, everybody? So what we are doing here is called binary search, where you are not going through each and every number. In linear search, what we do? We go through each and every number. In binary search, we don't do that. In binary search, what are we doing? We are saying, let's check the middle. But why are we able to check the middle? What is special property of this list? Sorted. If and only it is sorted, then only it will work. If it's not sorted, then this will not work. This method will not work. Because it's sorted, I check the middle element and I say, oh, should I go left or should I go right? Here, what did we do? It's 150. So we went left or right? Right. Because the number we're looking for, 206, is greater. Then I looked here, 310. Looking at 310, we went left or right? Louder. We went left. Why did we go left? The number I wanted was less than 310. And then we found over there. Okay. So this process is called binary search. Let's write the code for it. Let's write the code for binary search. Okay, so this is the array. All right. Let's first understand what's happening at each step. Let's say key is equal to int input. We want to check whether this key exists and at which index. Okay. So first things first, what am I going to do? I'm going to go to the middle point, the mid spot of this array. How do I calculate the middle point of this array? Well, how many elements are there in this array? Come on, count quickly. 9, right? So what will be the middle index? Yes, what is the middle index? Index 4. Very good. Okay. How do we calculate that? So what you'll do is, you'll say, see, this is the low index. Low equals to 0. High equals to the last element. How do I get the last index ever? Len of array minus 1. And mid is equal to low plus high divided by 2. So I got the mid element, mid index. Now I need to compare with the key that I'm looking for. I'll say if key is greater than ARR mid, then what should I do, everyone? My key that I'm looking for is greater than the middle element. What should I do? Go left or right? I'll go left or right? Louder, come on. Right. Okay. If key is less than array mid, then I should go left. We'll write the code for this. Okay. And the main one, if it is equal, if key equal to array mid, then what should we do? We'll say print key exists at index. What's the index here? Which index is it existing? Always 4. Every time key will exist at 4 only. How to get the index here? Mid. Very good. Mid. Okay. So what are we doing? We are doing 3 checks. One is if we found it, very good. Then it's at that index mid. Otherwise, I need to go right. What does it mean, go right? Means it's not at this 4. Means what? Go right means which indexes should I consider? 5, 6, 7, 8. Anywhere in this part of the array it is there. Correct? In this part of the array, it is there. Meaning I need to find midpoint of this part. Understood, everybody? I need to find midpoint of this part. Midpoint of that part, how will I find? How will I find midpoint of that part? Low plus high, yes, but low is currently 0. So what I'll do is I'll make low as this 5. High, let it remain 8. No problem. But low has to be now to the right side of mid. Understood this point? So I'll say, if I have to go right, I'll say low is equal to mid plus 1. That means move to the right side. Similarly, if the key is less than array mid, what I want to do? I want, if it's less than 43, I want anywhere between 0 to 3. I want the midpoint of that. How do I get the midpoint of that? Low, let it remain as is. High is equal to mid minus 1. Let's reduce the high over here. And then let's calculate mid again. So this calculate a mid. Let's calculate again. So now if I had to move to the left, the high has changed. If I want to move to the right, low has changed. But mid calculation will still be the same formula. Okay, everyone? And I'll keep repeating this. We're going to keep repeating this. So what I'll say is, till when do we keep repeating this? I'll give you 2 things. While high greater than equal to low, and ARR, and that's it. We'll keep continuing this till high greater than equal to low. And here, by the way, we'll break it. If we found the element, we are going to break it out. Okay. And again, we'll do one found equals to false. Here I'll say found equals to true. So if I come out of this loop, I'll say if found equal to false, print key not found. Okay. This is what we're going to do. Now, why this while loop? I'll tell you in just a bit. I'll tell you in just a bit why this while loop like this. So let's go. Let's see. This is the list. And let's say I am looking for the number 102. What is the index at which 102 is there? Which index is it there? 6. Very nice. If I type 102, it should say 102 exists at index 6. Is that correct? Okay. And if I am looking for, let's say, the number 7, what should it say? Not found. Okay. So let's do the dry run of this. Let's do the dry run of this. You have, let's say I am looking at the number 102. Let's see what happened. When I'm looking at 102, low is 0. What is the value of high, everybody? Low is 0. What is the value of high? Quickly, come on. 8. Mid is what? Mid becomes 4. So mid here is 4, means it is 43. Is high greater than equal to low? What's the value of high? High value is 8. So you have low 0, high 8, mid 4. Is high greater than equal to low? Is high greater than equal to low? 4th standard students can do this. Please tell me true or false quickly. Right? Yes, very nice. Now key equal to array mid. Is 43 equal to 102? No. Is 43 greater than 102? Is 43 less than 102? So now what happened? Low remains 0. High becomes mid minus 1, which becomes 3. What was mid value earlier? 4. So mid becomes 3. Sorry, high becomes 3. And now what is mid value now? 0 plus 3 divided by 2, which will be 1. So mid now becomes 1. You come here. Sorry, we are looking for 102. Okay, so I made the mistake here. Let's again go. We're looking for 102, right? Is 102 equal to 43? Is 102 greater than 43? Yes. Okay. So 102 is greater than 43, meaning that low should become mid plus 1, which is 5. So low becomes 5. High remains 8. When I calculate mid now, what is the value of mid? 5 plus 8 divided by 2 is equals to 6. Very good. All right. Now I go here. Is high still greater than equal to low? High. What is the value of low now? 5. High is 8. So what's the value? And this is 6. Is high still greater than equal to low? Yes. If I look at 6, what is 6? And 102. Is 102 equal to 102? Yes, it found the answer. Let's look at the other one, which was, what's the other one we tried? 7. Okay. So the key that I'm giving you now, input is 7. Low is 0, high is 8, mid is 4. And right now, as we started, low is 0, high is 8, mid is 4. Is 7 equal to 43? Is 7 equal to 43? No. Is Is 7 equal to 43? No. Is 7 greater than 43? No. Is 7 less than 43? Yes. So what is the mid value? What is the mid value? What was the mid value? Mid value here is 4. So mid minus 1 is, what will high value be now? 3. So low value is still 0. 0 plus 3 divided by 2 is 1. Very nice. Now I go here. I have high value is 3. Mid value is 1. Is key, which is mid is 1, is 9. Is 9 equal to 7? No. Is 9 greater than, sorry, is 7 greater than 9? Is 7 less than 9? Yes. What's the value of mid currently? What's the value of mid currently? 1. 1 minus 1 is 0. High becomes 0. Mid will become 0 plus 0 divided by 2, which is 0. Okay, very nice. Let's go here. Everything is 0. Is high greater than equal to low even now? Yes or no? Yes. 0 is 1. Is 1 equal to 7? No. Is 1 greater than 7? Sorry, is 7 greater than 1? Yeah? Yeah, is 7 is greater than 1. So, what was the value of mid? 0. So, low becomes 1. Mid is still 0. Here, mid becomes low plus high divided by 2. So, 1 plus 0 divided by 2. 1 plus 0 divided by 2. 0. Now I come here. Low is 1. High is 0. Mid is 0. Is high greater than equal to low? Is high greater than equal to low? No. So, this loop, we break out of this loop. And I say is found equal to false. Yes, it is. So 7 not found. 7 is not found. That's why we do high greater than equal to low, because as you keep searching, the low will become greater than high or high will become greater than low after a point. Okay, so that's our exit strategy over there. Clear, everyone? This is code for binary search. Please write it. Yes. Not visible. Is that better? Okay. Anyway, this code is also on the platform. Done, everybody? Written it down? Should I scroll down? Written, everybody? No? Okay, done now? Okay. All right, everyone. So give me a quick recap of what all we covered today. I'll not take anything new. Just give me a quick recap. All right, what all we covered today? 2D. I can't hear anything if you all talk at the same time. 2D lists. What do we cover in 2D lists? Matrix, okay. Taking input, very nice. Transpose, okay. Before transpose, printing row wise. Okay. In 1D lists, linear search, okay. Linear search, but we also saw one more thing. Taking input in 1D list. Okay. Linear search, then binary search. In binary search, only possible in sorted array or list. Okay. So everybody on the EDYST platform now, whatever I've taught you, you can all cover up this module. We covered nested loops. This is in the loops and 2D lists module. Nested loops covered. Loops and list of lists. This both you can cover. Meaning this entire loops and 2D list complete. Loops and 2D list is completed. What we covered today was this one, loops and lists and lists of lists. These two were covered. Of important algorithms also, I just covered searching. Searching has been covered. Okay. So tomorrow we will start with sorting. If possible, if you have covered till now, please watch the video of sorting and come tomorrow. It will be easier for you. If you already opened, please watch the video. bubble sort, selection sort, insertion sort. Please walk and read and come tomorrow. It will be easier for you to understand tomorrow. Okay. All right. Okay, everybody. Anybody has any doubts? Any doubts you have? If everyone is clear, please say clear. Clear, everyone? Okay. All right, everybody. So yeah, that's it for today. Thank you all. Yeah, I'll see you all tomorrow. Tomorrow, I believe session starts at 10:30. Yeah. Session starts at 10:30 tomorrow. Okay. All right. Thank you so much.